Question 6. The daily snowfall for January is given in the table below. So we've got this frequency table. We've got to calculate an estimate for the mean of the daily snowfall for 31 days of January. So if this was a normal frequency table, all we would do is we would times the two columns, but because it's a grouped frequency table, the first step is you need to find the midpoint of all of these groups. So the midpoint of the first one, between 0 and 5, is 2.5, so 2.5. Between 5 and 10 is 7.5. Between 10 and 20 is 15. Between 20 and 30 is 25. And between 30 and 50 is 40. So these are their midpoints, and we can times those by the number of days. So times that one by 10, times that by 16, times that by 4, times that by 0, and times that by 1. Because to find the mean, we need to add them all up and divide by how many there are. So we need to do 2.5 times 10, that's 25. Don't forget you've got a calculator, this is the calculator paper. 7.5 times 16 gives you 120. 15 times 4 is 60. 25 times 0 is 0. 40 times 1 is 40. You need to add all of them up then to get 245. We need to divide that by the total frequency, which is this column, but it's the 31 days. So we need to divide that by the 31 days, and we get 7.9 for the mean. Right, circle either true or false for each of the following statements. So the table above shows that there was definitely snowfall on each of the 31 days in January. Don't have enough information to say that's correct, so all it's telling us is the daily snowfall and the number of days. It doesn't say that there's exactly snowfall each day, so we haven't got enough information, so the first one for that is false. There were 16 days when the daily snowfall was less than 10 centimetres. So less than 10 is this one, and it's got to be 16 under here. Well, no, both of those are 26, so that's not right. There was only one day with snowfall greater than or equal to 20, so it's got to be bigger or greater than 20. So that's these 2 days here, and they've got to add it to 1, which they do. So yeah, that one's true. The modal group also contains the median daily snowfall. So the modal, the most common, we look for the highest frequency, which is 16. So the modal group is 5 to 10. To find the median, well, 31, the middle one would be the 15th and a half. So the 15th day would be in here. So yeah, the median is the mode. So that one's also true. Part C, for the 28 days of February, the mean daily snowfall was 9 centimetres. On the 1st of February, the snowfall recorded was 63 centimetres. Calculate the mean snowfall for the 27 days, so from the 2nd to the 28th. So they had all their days from February and they added them all up. So to find the mean, we add them all up and we divide by how many there are. So they divided by the 28 and they got 9. So to find out what they added up to, we can do the 28 times the 9. So they did add up to 252. So all the 28 days added up to 252. But we're taking out the first day, so we don't want the 63 anymore. So if we do 252, take away our 63, we get 189. And this time we're dividing it by the 27 days left. So we want to divide that by the 27, and when you do that on your calculator, you get 7. Okay, Bronwyn and someone else has decided to keep alpacas on their farm in Patagonia. She knows it's possible to keep between 4 and 6 alpacas on each acre of suitable farmland. So they have 3 hectares of farmland that they want to use to keep the alpacas. She knows that 1 acre is 4,046.86 meters squared. 10,000 meters squared is 1 hectare. Use this information to advise Bronwyn of the number of alpacas they could keep on their farmland. State any assumptions that you make. So we know we've got 13, and we know that each one is 10,000. So if we do 13 times our 10,000 meters squared, that gives us 130,000 meters squared. We basically want to see how many acres we can get. So if we divide the 130,000 by the 4,046.86, we can see how many acres we need for the alpacas, each alpaca. So we can go 130,000 divided by the 4,046.86. That gives us roughly 32. So we have 32 acres. And they say they can keep between 4 and 6. So you can use either 4, 5 or 6. So this is your assumption you're making now. If you're either choosing 4, 5 or 6. So we'll go in the middle and we'll do 5. Lots of the 32 gives us 160. They can have 160 alpacas. So the assumption is that I've used the middle between 4 and 6. Okay. Another assumption is that you could say all the 13 hectares are like suitable and none of them are like bad. Right, next one. Bronwyn decides to place a cylindrical water container in the small paddock on a farm. The water container has a diameter of 1.4 meters. Scale diagram opposite shows a small paddock on the farm. The small paddock is rectangular, measuring 7 meters by 5 meters. Okay, we're going to have to use a compass for this one, which I don't have. So she decides to place the centre of the water container so that it is equidistant from the south fence and the east fence. So the first thing we're going to have to do is we're going to have to cut this angle here, so from the south to the east. So you're going to need to cut that there. So you would draw with your compass, draw a line there, here, and then here from your compass point there, and draw a straight line going through. Let me do that. So straight line going through. Then it's going to be 3 meters from the south fence. Well, they told us 2 centimeters is 1 meter, so it's got to be 6 centimeters up from here. So measure 6 centimeters up. So it's going to be along there somewhere. And then the water container, so wherever your circle is, ask your teacher to show you how to do this one with a proper compass, because I'm just guessing here. And they've said it's got to be 1.4 meters here, and we are in centimeters, so you've got to double that for your diameter. So your radius is going to be 1.4 centimeters and your diameter 2.8. So ask your teacher how you could do that one properly with a compass, because I can't show you on the iPad. Right, the water container holds 900 litres of water when full. Calculate the height of the water container in centimetres. Right, so they've told us the volume of the cylinder basically, but they've given it us in litres. So we know 900 litres as a volume, we would change that into centimetres cubed. So there's we need to times that by 1,000, because there's 1,000 centimetres cubed in a litre. So if we times that by 1,000, we'll get 900,000 centimetres cubed. So we know the volume of a cylinder is pi times the radius squared, and then that times the height. Something you need to know. Well, the area of the cross section times the height is at the front of your book. So the area of the cross section is going to be area of a circle. So we've got the volume is 900,000 centimetres cubed. We're going to pi the radius is going to be, so if the diameter is 1.4 meters, radius is going to be half of that, so 0.7 meters. We're working with centimeters, so if we times that by 100 we get 70. So the radius is 70 squared, and we're working out the height, so we don't know the height. So we've got the 900,000 is pi times 70 squared times height. So if we do pi times 70 squared, we get 70 squared. I think we get 0.154. Hang on, let me check that on a calculator. So pi 3.14 times 70 squared. Yep, so we're going to divide that then. So we got our 900,000. If we divide that by the pi 70 squared, we should get our height. So whatever you get for pi 70 squared, which is 154 I got. So if you divide that, you should end up with your height to be 58.5. Okay, currency in Patagonia is pesos, so we buying some fleeces. He wants to know how much it's going to cost in pounds. Right, so if he buys 80 in January, 20 March, 100 in April, well, all we need to do is times those together and then divide it by our exchange rate. So in January he's got the 80, so in January we've got the 80 times the 1920, so this is how much it's going to cost. So we've got 1536 pesos, but we need to change that into pounds, so you divide by exchange rate. So if £1 is 15.45, we can get pesos into pounds by dividing it. So it's divide by the same times by the difference. So once you do that on your calculator, you get £99.29. In March, he buys 20, and they are £22 or 22.30 pesos. That gives you 446 pesos. Again, we want that into pounds, so we're gonna, our new exchange rate is 15.21, so we divide that by our 15.21 to get it in pounds, which is 29.32. And then April, he's got 100, and they cost 24.50. So once you times those, you get 2450. Again, we're changing that into pounds. New exchange rate of 14.93 to get 164.10. So, I mean, we just need to add these up now. So to find out how much he paid in total, so we got the 99.29, add our 29.32, add our 164.10, we should end up with £292.71, and that is correct to the nearest penny. So quite straightforward one. Question 8. We got handmade socks knitted using pure cashmere wool are very expensive to buy. Rowena buys cashmere wool in 20-gram balls, so each ball of cashmere wool costs £1.42. She pays her sister £8 to knit each pair of socks. 135 grams of cashmere wool is used to knit each pair of sock. She sells 40 pairs at £18.95. What percentage is her profit? Give your answer correct to two significant figures. So, she needs 165 grams of wool to make each pair of socks. She makes 40 socks. So let's see how much wool she needs. She needs 5,400 grams needs. Okay, so that's how much wool she needs. And if they sell it in 20-gram balls, well, now we need to know how many balls she needs. So if we divide that by our 20 grams, we can see that she needs 270 balls of wool. So each ball costs £1.42, so we can see how much all the balls cost. So we've got the 270 times our 142 to give us £383.40. So that's how much it costs to make them. However, she's given her sister £8 per sock. Yep, per sock. So that's £8 times the 40 socks. So that's another £320 she's given to her sister. So the cost of making the socks, we got the £383.40, that's the balls. Then her sister, so she's got to pay £703.40. So that's how much she's paying to make all these socks. And then she sells them for £18.95 per sock, per pair. I wouldn't pay that much for socks. So selling 40 for £18.95. So she's making £758. It's a lot of money for some socks. So if that's how much she's making, and that's how much it costs, just take them away to see the profit. So we can do 758, take away our 703.40. That gives us £54.60. It's not a lot of money for that effort. So we want the percentage profit. So all you need to do is take your profit, and you're going to divide that by the amount of money you spent. So that is a profit of 7.8%. Times it by 100 to get your percentage. So 7.8%. And that's two significant figures because that's two numbers. 7.8%. I wouldn't do that for some socks. Okay, question 9. Bethan has a plan of her rectangular lawn which is labelled A, B, C, D. She wants to cut out a triangular flower bed from her lawn, labelled G, H, D. Bethan decides that AG equals GD. So these two lines, A to G, this line's AG, oh no, AG should be 1 to 2. So whatever that is, 1, that is double it. Then she says that DH equals HC. Okay, so these two are the bits that equal. So those are exactly half. And they've got up here. That one is 6.8. Well, half of that is 3.4. So we know that length there is 3.4. That length is also 3.4. And they've told us this is in the ratio 1 to 2. So 1 and 2 parts, that's a total of 3 parts. So if it's 4.8, we can divide that by 3. 4.8 divided by 3 is 1.6. So one part is 1.6, so that length over here is 1.6. And then 2 lots of that is 3.2. So those are all the lengths we need. Don't even know what we're going to do yet. I haven't read the question. Calculate the length of GH. Right. Pythagoras. So we've got a nice triangle here. So we've got to calculate that length. Now we need the hypotenuse. When we need the height, we need it, so we need to add it into our life. We need some height. If you've got it, then you need to take it away. So we square, add, and then square root. So we're going 3.2 squared, add 3.4 squared, whatever that is, I think it's 2181. We need a square root 2181 to get 4 0.7 centimeters. Right, the flower bed GHD is to have a flexible edging strip placed around its perimeter. The edging strip costs £3.50 per metre and can only be bought in meters, strips of complete meters. So how much edging strips cost? How much will the edging strips cost, Bethan? And what length of the strip will be left over? Give your answer in centimeters. So we need the perimeter. So we've got all the lengths we had, 3.2, the 3.4, and then we worked out that it was 4.7. Even if you got the 4.7 wrong, use your number because you'd still get full marks for this question. So that gives us the 11.3 meters needed. Now, if we need 11.3 and they only sell them in meter strips, we're going to have to get 12. So we have to round up, and we need 12 meter strips. So if we need 12 and they cost £3.50 each, 12 lots of 350 of £42. So we know they cost £42, and she's bought 12 and she only needed 11.3, so that's only 0.7 meters that she doesn't need. Or they want it in centimeters, so just go times that by 100, and that's 70 centimeters. So it cost her £42 and she got 70 centimeters left over.